Today's lesson is about investigation of the slope of a tangent line.
Now let's investigate the graph y equals x squared. I will move this A on the curve y equals x squared, and we can observe how the slope of a tangent line change. When x less than 0, you could see the slope of tangent line is negative. Then the curve for x less than 0 is decreasing. When x equals to 0, then the slope of tangent line equal to 0. We could see the point 0, 0 is the minimum of the graph y equals x squared. When x greater than 0, you could see the slope of tangent line is positive. For this interval, x greater than 0, the graph of y equals x squared is an increasing function. If we want to figure out the specific value for the slope of tangent line when x equals to negative 10, for example, I will move this A to x equals negative 10. Make sure over here the point is negative 10, 100. Then you could see the slope tangent line equals negative 20. When x equals to negative 5, make sure over here it's negative 525 because that's the correct point on the curve. Then the slope of a tangent line equals negative 10. When x equals negative 1, if it's hard for you to locate this negative 1, 1, you can do the or zoom in. You check. Zoom in will make you easier to locate this negative 1, 1. Then the slope of a tangent line at x equals negative 1 is negative 2. X equal to 0, then slope of tangent line equal to 0. When x equals to 3, make sure here the 3, 9. Then the slope tangent line equal to 6. Can get when x equals to 7. Then the slope of tangent line equals 14 when x equals to 8. Then the slope of tangent line equals 16.
After we investigate the y equals x squared graph and also the slope of a tangent line, we can fill in this table. For interval x greater than 0, we know the slope of a tangent line is positive. For example, over here, and this will be the tangent line. You could see the slope for this tangent line is positive. When x greater than 0, you could see the graph is increasing because from left side to the right side, the graph is increasing, going up. when x equal to 0, that means for this minimum value, the slope of tangent line equals to 0 because the tangent line is a horizontal line. When x less than 0, the slope of a tangent line is negative, just like this one. This is a slope less than 0. And for this interval, this part of graph x less than 0 is decreasing. And when x equals negative 10, the slope of the tangent line is negative 20. When x equals negative 5, we got negative 10. X equals negative 1, negative 2, 0. Here's a 6, 14, and 16. Notice x is included in the table. Do you see a pattern in the gradients? That means the slope of a tangent line. What's the formula for the gradient of the tangent to y equals x squared? Let's analyze this table. Try to figure out the pattern. Let's use this symbol. Y prime equals x squared prime. That equals 2x. You could say for all x you multiply by 2, you will get the slope of a tangent line.
Now let's investigate the graph y equals negative 3x squared. I will move this A, then check how the slope of a tangent line change. When x less than 0, you could see the slope of a tangent line is positive. When x equal to 0, the slope of a tangent line equal to 0. When x greater than 0, you could see the slope of tangent line is negative. When x less than 0, the slope of a tangent line is positive. You could say the graph is increasing. And when x equal to 0, the slope of tangent line equal to 0. This point is the maximum of the graph. Then when x greater than 0, the slope of tangent line is negative. Then for this interval, x greater than 0, the graph is decreasing. We want to look for the specific value of slope of tangent line when x equals negative 10, negative 5, negative 1, and so on. Let's check when x equals negative 10. X equals negative 10. You could say negative 10, negative 300. That's the specific point on this y equals negative 3x squared. Then your slope equals 60. When x equals negative 5, see negative 5, negative 75, then the slope of a tangent line equals 30. Then when x equals negative 1, sometimes it's hard to find like a negative 1 over here. you need to change the zoom of this graph. So this is the way we find the -1 now. So I found the -1, -3. That's the point on this curve. Then your slope equals 6. Slope of tangent line equals 6. Keep moving and you will find the for 3. For 3, that will be -18. So using the same way, get the x equals 7 or x equals 8.
After you investigated the graph y equals -3x squared, we can fill out the table. When x less than 0, slope of a tangent line is positive. Like this is the one, slope greater than 0. You could say for this interval, the graph is increasing because the graph going up from left side to the right side. Then when x equals to 0 is here, then the slope of a tangent line equals to 0. And also this point is the maximum of the graph. When x greater than 0, you could say the slope of a tangent line is negative. This slope of a tangent line is negative. And the graph going down from left to right, so it's decreasing. We also figure out the value for slope of a tangent line when x equals to different value. When x equals -10, this will be 60. 30, 6, 0, -18, -42, -48. And we can figure out the pattern for this table. We write down y prime equals -3x squared prime equals -6x.
Now let's investigate the graph y equals x to the third power. We move this a, then you check the sign of a slope of tangent line. You could draw a conclusion that slope of a tangent line all greater than or equal to 0. It's all positive when x greater than 0, and when x less than 0, it's all positive. Because for y equals x to the third power, this graph is an increasing function. It's increasing. Therefore, the slope of a tangent line is positive. When x equals to 0, then the slope of tangent line equal to 0. But for this 0, it's not minimum, it's not maximum. The slope of a tangent line equals to 0 for this 0, 0. We call that stationary inflection point, because at this point, the concavity is changing. It's from concave down change to concave up. We call the point that connect from concave up to concave down or from concave down to concave up. It's an inflection point. At this point, the second derivative equals to 0. When the first derivative equal to 0 and the second derivative equal to 0, we call this point is a stationary inflection point. If we want to figure out when x equals to -5, what's the slope of tangent line, I will move the A, make sure x equals to -5. And y will be -25. Yeah, make sure the value is correct. Then you could see the slope of a tangent line equals 75. When x equals to -4, if it's very hard to locate that -4, -64, you can do the zoom in. Then it's easy for you to locate. You see, it's -4, -64. Then you could see the slope of a tangent line equals 48. Now we look for when x equals to -2. And the slope of tangent line equals 12. When x equals to 0, then the slope tangent line equal to 0. When x equals to 1, then the slope of tangent line equals to 3. When x equals to 5, then you could see the slope of a tangent line equals 75. Let's go to investigation 3. This is about y equals x to the third power. And when x greater than 0 or x less than 0, the slope of tangent line is positive. And you could see the graph is increasing. For all x, it's all real numbers. When x equals to 0, the slope of a tangent line equals to 0. But this 0, 0 point on the graph is not minimum, it's not the maximum. We call this point is a stationary inflection. We know this graph is a concave down, and this is a concave up. Inflection point means the change of concavity. You could say for this graph, it's a concave down, and this one is a concave up. In other words, at 0, 0, concavity changes. We call this is a inflection point when concavity changes. So no negative slope of a tangent line for y equals x to the third power. We also got the value for
slope of a tangent line when x equals a different number. When x equals to -5, then the slope of a tangent line, that's 75. X equals -4, you will get the 48. If it's a -1, that's a 3. Here's a 0. 12, 27, and 75. We can get a pattern for this table. It will be a quadratic function, so we can write down y prime equals x to the third power prime equals to 3x squared. Now let's talk about derivative. The gradient function of y equals f of x is called its derivative function, y prime, or dy by dx. In other words, the derivative of f of x is the instantaneous rate of change of a function at a point, or a slope of a tangent line, or the gradient of a tangent line. Now let's look at this graph. Slope of tangents, we call that derivative. In other words, slope of a tangent line equals f prime of x, means derivative of f of x. The following 6 things means the same thing. We are looking for the derivative function. When you say differentiate the following, find the derivative of the following. Find dy by dx. Find f prime of x or y prime. Find the slope of a tangent line. Find the gradient of a tangent line. All this means derivative. From the investigations of the slope of a tangent line in different function, we can draw a conclusion. The derivative of f of x greater than 0, which means the slope of a tangent line is positive on certain interval s, when the function is increasing in that interval. Derivative of f of x less than 0, which means the slope of a tangent line is negative on certain interval s, when the function is decreasing on that interval. When derivative of fx equals to 0, which means the tangent line is a horizontal line, or the slope of tangent line equal to 0 at a minimum point or maximum point, or stationary inflection point. This is the rule you really need to remember, so that we can analyze the graph to decide in what interval the derivative is negative or positive or equal to 0.
Now let's explore the slope of a tangent line of a linear function. This is the value of a derivative. You could say from here, when I move this a, basically I change the slope of a linear function. Then you will see the value of derivative is changing when I move this a. In other words, when the slope of a linear function is changing, then the value of a derivative is changing. How they change? When slope equals to 7, you could say the derivative of this linear function equals 7. You will see exactly the slope of a linear function equals the value of a derivative of a linear function. If I move this b, that means your y-intercept changing. And then you could say the slope of a linear function is changing. And the slope of the linear function equals the value of a derivative of this linear function. The reason why the slope of a linear function equals the value of a derivative is that any point on the linear function, when you draw the tangent line, it's overlapped with the original linear function. In other words, the slope of a tangent line equals the slope of the linear function.
We also draw the conclusion. We know that derivative of x to the third power, that equals 3x squared. Derivative of x squared, that is 2x. Derivative of x, that is equals to 1. So we can draw a conclusion that derivative of x to the nth power equals n times x to the n minus 1th power. Remember, this is a very important rule we call power rule of a derivative. Drop down this n to the front. Then your exponents minus 1. Then we also know the derivative for negative 3x squared, that is negative 6x. In other words, we can change negative 3x squared, that derivative equals negative 3 times x squared, you do the derivative, so that you can get negative 3 times 2x equals negative 6x. So we can guess the rule for say x squared. We do the derivative, it will be say times 2x. And for say times x to the nth power, that derivative equals say times x to the nth power, we do derivative. Then we can get the say times n x to the n minus 1th power. So we can draw a conclusion that derivative of a constant number will be 0 because the slope of a constant number, that's a horizontal line, slope equals to 0. For x to the nth power, we do derivative, it equals n times x to the n minus 1th power. For say times u of x, when we do the derivative, it equals say times, I can write down u prime of x.